Hi everyone, and well done for finding the next flip video. This one's all about finding missing angles, and this is the aiming higher version. Start off with, we're going to have a look at different types of angles. So you can see here, you'll be familiar with our right angle that we've got here. That of course is a 90-degree angle, and we know that all of the angles around a point, a whole circle, is 360 degrees. So we know here that this angle is a reflex angle, and we know it's got to make 270 degrees. Because if I take away the 90 degrees from the whole turn, then this bit here has got to be an angle of 270. If I'm looking at angles around a line, like for example the angle from here to there, this kind of turn, that of course is half a turn, 180 degrees, like a protractor. Whereas if I'm looking at the angle around a point, if I'm going from one side to the other, that of course is 360 degrees. A 360 degree whole turn. So we were talking last week about different kinds of triangles, and this one here of course is an equilateral triangle, all sides the same length and all angles equal. Now we know that all the angles in a triangle add up to 180 degrees, and so if I've got an equilateral triangle with three angles the same, then of course the 180 degrees I'll have to divide by those three angles to work out that they are angles of 60 degrees each. And on the protractor that would be a 60 degree, another 60 degree to 120, and then the third one. So those three angles add up to 180 degrees, just like all angles in a triangle do. Now here, this one of course is our isosceles triangle, because it's got two sides of the same length and two angles that are the same. Now in an isosceles triangle, if I know, for example, one angle here, that will allow me to work out the size of the other two angles, which of course are the same as each other. And then finally, of course, we've got our right angle triangle. Now, the thing, of course, we know about that is that one of its angles is 90 degrees. And then we'll know that these two angles will also have to add up to 90 degrees, so that the triangle has angles that add up in total to 180. See if you can use that information to work out the three missing angles, the three blue angles here. So pause the video and have a go. So starting with the triangle on the left hand side, of course I know that it's got one angle of 30 degrees, and I know that these two angles are the same, and that overall it must add up to 180. So if I do 180 and take off that 30 degree angle, I will of course have 150 degrees left that those two angles must add up to. And so then if I divide that 150 degrees by those two angles, I know that each angle must be 75 degrees, which of course looks about right when you think that that would be about a right angle. For the second example here, again I know that the three angles have got to add up to 180 degrees. If I add 125 and 32, I will get 157 degrees. And then if I take 157 off 180, I'd probably count on, think 3 more to get to 160, and then 20 more to get to 180, 23 degrees. And then finally, of course, this angle's 90, this angle's 55. If I add them together, that's 145. So the remaining angle here must be 35 degrees, so that all three angles add up to 180. If you have a look at the examples on the top left then, I hope you'll be able to work out missing angles like, for example, this one. So you'll think, well, if I take off the 124 degrees from 180, that'll leave me with 156. And then I need to halve the 156 to work out what each angle will be. And of course it would be 78. And similarly, you'd know for this example here that this angle would have to be 105, because I know that a whole turn would be 180 degrees. And then this part of it is 75 degrees, so the other part must be the rest, the 105 degrees. See if you can use that information to work out the answer to the question below, what this missing angle is here. Pause the video and have a go. So in a very similar way, I can work out this angle, and crucially, of course, this angle here. I'll do 180 degrees, take away this 28 degrees to give me 152 degrees, divide that by these two angles, and that will show me that that angle there, for example, is 76 degrees. Now, if I know that this bit is 76 degrees, I'll be able to work out this bit here by doing 180 degrees so a half turn, take away that 76 degrees to give me an answer of 104 degrees. And again, I can see that, I know that this angle must be more than 90, because I can see it's slightly more than 90 as well, which confirms that 104 is a realistic answer. So have a go at this question too, finding angle X. Pause the video and we'll go through it in a moment. So to answer this question, there's a few things to establish first. First of all, of course, this angle is a 90-degree angle because it's a rectangle, and we know that rectangles all have 4 90-degree angles. And, of course, an equilateral triangle, as we mentioned at the start of the video, must have 3 angles of 60 degrees, crucially including this one. And so, therefore, if we add up the 12 degrees here and the 60 degrees here, that's a total, of course, of 72 degrees, and so that means the angle X must be a further 18 degrees to make up the total of 90 degrees of that right angle. Okay, so finally, have a go at this question. It's a level 6 question, and there's 2 parts to it. So, the reasoning part, and then calculating the size of angle A. Pause the video, and we'll have a look through in a moment. So first of all, is this shape a regular pentagon? Well, of course, it is regular in the sense that it's got all sides the same length, 5 sides the same length. But of course, the answer actually is no, on the grounds that it doesn't have equal angles. You can see here we've got right angles at the bottom and angles of 150 degrees here. And so no, of course, it's not a regular pentagon. And to calculate the size of angle A, I first visualised this problem by cutting the 150 degree angles to split this shape up into a square with 4 equal sides and this triangle. And of course, that would mean the 150 degrees here would be split into the 90 degrees of the square and then the 60 degrees here. Equally, of course, this would be 60 degrees. Now, if these 2 angles are 60 degrees, of course, the top one would have to be 62 for the angle for that triangle to be 180 degrees in total. Also, you might notice that it says that all of the sides are the same length. So this length and this length and this length are the same. And of course, this bottom length is the same as the length here. So essentially, what we've got at the top is an equilateral triangle. And of course, we know that the angles of an equilateral triangle are 60 degrees. Well done. Thanks for watching the video. And again, we will see you in class ready to go next week.